Right now, as you sit there, the ground beneath you is spinning. It's rotating from west to east, completing a full turn once every 24 hours. Now, consider the size of our planet. To do that, to make that full rotation in a single day, a point on the equator has to be moving at approximately 1,670 kilometers per hour. That's faster than the speed of sound. Let that settle for a moment. You are, right now, spinning faster than a bullet fired from a rifle. If you were at the North Pole, the speed would be less, but you'd still be moving at a pace that would make any race car look like it's standing still. Imagine standing on the edge of a giant carousel, one the size of a continent, spinning so fast that the world around you becomes a blur. That is the reality of our planet's rotation. Yet, you feel nothing. No wind screams past your face. Your coffee doesn't slide off the table. When you jump in the air, the ground doesn't spin away beneath you. Why? The answer is deceptively simple, and it's the key to understanding everything that follows. Everything is moving together. The ground, your chair, the air in the room, the very atoms of your body, all of it is locked in this same smooth, steady, relentless spin. There is no difference in motion between you and your immediate environment. Our senses are built to detect changes in motion, acceleration, deceleration, a sudden lurch to the side, but a constant, unwavering velocity, no matter how immense, feels exactly the same as being perfectly still. It's a trick of physics, a loophole in the way we experience the universe. This rotation is the engine of our days and nights. It's not that the sun rises and sets. It's that we are constantly turning away from it and then back towards it. The great celestial clock in the sky is, in fact, a clockwork within the very ground we stand on. For ancient it was the most logical thing in the world to believe the heavens revolved around a stationary earth. Every one of their senses confirmed it. The sun's dependable arc, the stately procession of the stars, it all pointed to a universe that moved around us. But they were wrong. We were the ones moving all along. This was the first great crack in the illusion of stillness. A crack that began with astronomers like Copernicus and Galileo, who dared to look at the evidence and trust the math over their own senses. It was a shocking, almost heretical idea. We were not the fixed center of creation. We were travelers on a spinning sphere, and this is where the first whisper of a deeper truth begins to surface. If this spin, this dizzying, supersonic rotation, is completely imperceptible to us, what else is? What other, even vaster movements are we missing? The spin gives us our day. But there is another motion, a slower, grander journey that gives us our year. And it is here that our speed takes a truly dramatic leap. The Earth's rotation is just the first gear in a cosmic engine. The second gear is our orbit. We are not just spinning in place. Our entire planet, this giant spinning top, is also falling. It's falling around the sun. We are in a perpetual, graceful freefall, locked in a gravitational dance with our star. The path of this fall is a vast, elliptical loop, nearly 940 million kilometers in circumference. To complete this loop in 365.25 days, our planet must travel at a speed of roughly 107,000 kilometers per hour. Compare that to our rotational speed. We've just jumped from 1,670 kilometers per hour to 107,000 kilometers per hour. In the time it takes you to read this sentence, the Earth has carried you tens of thousands of kilometers through the void. Every second, you are 30 kilometers further along in your journey around the sun. Think about that. Blink, and you're 30 kilometers away from where you were. Breathe in, and you've traveled another 30. This orbital motion is the reason for the seasons. It's not, as many think, because we get closer or farther from the sun, the difference in distance is actually quite small. It's because the Earth is tilted on its axis. As we travel around our year-long loop, this tilt means that first the northern and then the southern hemisphere leans towards the sun, receiving more direct light and longer days. Our annual calendar, the rhythm of spring, summer, autumn, and winter, is literally a map of our position along this colossal orbital path. And still, you feel nothing. The vacuum of space offers no resistance, no friction to slow us down or make our motion known. The sun's gravity curves our path, but it does so with such perfect consistency that there is no jerk, no bump, no sensation of turning. It is the smoothest ride imaginable. So now, the picture begins to shift. You are no longer just a person sitting still. You are a passenger on a world that is both spinning like a top and soaring like a slingshot around a star. You are moving at two immense speeds simultaneously, layered one on top of the other, and you are blissfully, utterly unaware of it all. But we have to go further. Because even this combined, staggering velocity of spin and orbits, not the whole story. In fact, it's barely the beginning. The sun, the anchor of our entire solar system, is not a fixed point in space. It, too, is moving. And it is taking us with it. Our sun is a star, one of roughly 200 billion in the Milky Way galaxy. And like all stars in this great cosmic city, it is bound by gravity to orbit the galactic center. Our solar system, from the sun out to the farthest icy comets in the Oort cloud, is a single, coherent structure, a traveling family hurtling through the galactic landscape. The scale of this motion is almost impossible to comprehend. The Milky Way is a vast spiral disk. Our sun, and us with it, is located about 27,000 light-years from the center. Out in one of the spiral arms, to complete one full revolution around this galactic cora, single galactic year, takes US approximately 230 million Earth years. The last time our solar system was in this same position in the galaxy, the earliest dinosaurs were just beginning to appear on Earth. The entire history of human civilization, every empire, every discovery, every life that has ever been lived, is less than a blink of an eye in the context of a single galactic orbit. And how fast are we moving on this immense journey? The sun, and Earth with it, races around the galactic center at about 828,000 kilometers per hour. We have now escalated from 107,000 kilometers per hour to over 800,000 kilometers per hour. This is 100 times faster than a speeding bullet. It is a velocity so immense that it dwarfs our planetary motions into insignificance. Let's pause and add it all up. You are spinning, you are orbiting, and you are spiraling around the heart of a galaxy. 3 distinct nested motions, each one faster and grander than the last. The combined sensation of all this movement, a perfect, unbroken stillness. The reason, again, is that sublime, shared motion. The atmosphere rotates with us. The oceans follow our orbit. The sun's gravity binds the entire solar system together in this galactic race. There is no outside force pushing against us, no wind of galactic motion to ruffle our hair. We are moving in perfect sync with our entire local environment. Motion in the vacuum of space only feels like motion when it's relative to something else. When everything moves together, it is indistinguishable from rest. This is the illusion we live inside, a quiet storm of physics that feels like peace. But the story doesn't end at the edge of the galaxy. The Milky Way itself is not a stationary island. It is adrift in an even greater cosmic ocean, pulled by the gravity of neighboring galaxies and the vast, unseen webs of dark matter that thread the universe. Our galaxy is moving toward our colossal neighbor, the Andromeda Galaxy, at a speed of about 400,000 kilometers per hour. Billions of years from now, these two giant spiral galaxies will meet and merge in a slow, silent dance, their stars passing through each other like ghosts. So far apart that collisions are almost unheard of, and even this, the motion of our entire galaxy, is part of a larger flow. Astronomers can measure our movement against the oldest light in the universe, the cosmic microwave background, the faint afterglow of the Big Bang against this ultimate backdrop. Our entire local group of galaxies is speeding through space at over 1.3 million miles per hour. So, let's take a final tally. You are spinning, orbiting, and spiraling around the galaxy, which is itself drifting and falling through the universe. You are a passenger on a ship of unimaginable scale, moving upon motion upon motion. You are, at this very moment, traveling at a total speed of hundreds of kilometers every single second. You are, quite literally, in a different part of the universe with every beat of your heart, and yet the room is quiet. Your breath is calm. The world outside your window is, to all appearances, perfectly still. This is the central mystery, the beautiful paradox we are going to explore. How can such violence of motion feel so much like peace? How can we be hurtling through a dynamic, ever-changing cosmos, and yet experience our lives within a bubble of perfect tranquility? We've peeled back the first few layers. We've seen the spin, the orbit, the galactic spiral. We've seen how the illusion is maintained through the physics of shared motion and the limitations of our own senses. But this is only the surface. To truly understand how Earth moves through the galaxy, we must go deeper. We must look at the evidence hidden in the stars themselves, in the wobble of a pendulum, and in the very fabric of space and time. We must ask not just how we move, but what this grand, silent journey means for us, for our planet, and for our understanding of home. But this revelation leads us to an even deeper, more perplexing layer of the mystery. We've proven we're moving. We've measured the speed. We've mapped the paths. But all of this motion, from the spin to the galactic orbit, is described as a perfect, stable, clockwork harmony. The planets don't spiral into the sun. The solar system doesn't fly apart. The galaxy holds its shape. This stability is what creates the illusion of stillness. It's a stability so robust that it has allowed life to arise and evolve over billions of years. This forces a question that goes beyond mere motion and strikes at the heart of our existence. In a universe governed by chaotic forces and immense speeds, How is this perfect balance maintained? What invisible hand keeps this cosmic dance in check, preventing our world from careening into the sun or flying off into the eternal void? The stillness is an illusion, but the stability is not. It is real, and it is the most precious condition for our existence. Imagine, for a moment, that you could reach out and simply stop the earth, not slowly, instantly, as if you flipped a switch and halted our planet's orbital motion around the sun. What would happen? The consequences would be both instantaneous and apocalyptic. The first thing you would feel is nothing for a fraction of a second, and then everything would cease to be. With our forward momentum of 107,000 kilometers per hour suddenly gone, the only force left acting on our planet would be the sun's gravity. We would immediately begin to fall, not in a graceful curve, but in a death plunge, straight down the sun's gravitational well. We would accelerate faster and faster as the sun's immense gravity pulled us in. Within weeks, the temperatures on Earth would become unbearable as we sped closer. The oceans would begin to boil. The atmosphere would be stripped away by the solar wind. Eventually, our world would either be vaporized by the sun's ferocious heat or torn apart by its tidal forces. Adding our mass to the star that once gave us life, this terrifying thought experiment reveals the first pillar of the invisible architecture. Motion is not just happening. It is a necessary, active force for survival. Our orbital speed is precisely what keeps us from falling into the sun. It is our shield now. Imagine the opposite. What if the sun's gravity suddenly vanished? In that instant, the tether holding us in our curved path would be cut. The Earth, obeying Newton's first law, would continue moving in a straight line tangent to its orbit. We would fly off into the freezing, dark depths of interstellar space, a frozen, lifeless rock forever adrift. Our planet would become a ghost ship, its light and heat source gone, its journey meaningless. This reveals the second pillar. Gravity is not a prison. It is the anchor that gives our motion purpose and shape. It is the force that bends our straight-line path into a closed loop, a continuous, falling orbit. An orbit, then, is not a thing of magic. It is a state of perpetual tension. It is the perfect, continuous balance between the planet's desire to fly off in a straight line, its momentum, and the sun's relentless pull to draw it inward, its gravity. We are forever falling towards the sun, but our forward motion is so great that we constantly miss it. We are in a state of controlled, eternal freefall. This same elegant balance scales perfectly. From the smallest satellite to the largest galaxy, the moon is balanced in its orbit around Earth. Our entire solar system is balanced in its orbit around the galactic center. In every case, the speed of the orbiting object is precisely calibrated. Too slow, and it falls in; too fast, and it escapes. We exist in the narrow, habitable zone of velocity, the Goldilocks speed that is just right for stability. This concept of balance is beautifully illustrated by a simple, earthly analogy: a ball on a string. If you swing a ball on a string around your head, you feel a constant pull. The string is like gravity, pulling the ball inward. The ball's momentum tries to carry it away in a straight line. The tension in the string is the balance between these two forces. Now, imagine the string is cut. The ball doesn't magically fly towards your hand. It flies directly away, along the tangent of its last moment of swing. This is exactly what would happen to Earth if the sun's gravity disappeared. But our cosmic architecture has even more layers of subtlety and grace. The balance isn't just a crude, static tug-of-war. It's a dynamic, responsive system. This is where the genius of Johannes Kepler and Isaac Newton illuminates the deeper mechanics. Kepler, studying the meticulous observations of Tycho Brahe, discovered that planets do not orbit in perfect circles, as had been assumed since the time of the Greeks. They travel along elliptical paths, with the sun sitting at one focus of the ellipse. This was the first clue that the balance was more nuanced. Furthermore, he found that a planet does not travel at a constant speed. It speeds up when it is closer to the sun at perihelion and slows down when it is farther away at a phelion, closing parenthesis, y. Think of it as a cosmic exchange of energy. As a planet falls inward towards the sun, gravity accelerates it, converting gravitational potential energy into kinetic energy, the energy of motion. It's like a roller coaster car picking up speed as it plunges down a hill. This extra speed gives it the momentum to then climb back up the gravitational hill, away from the sun. As it climbs, it slows down, converting its kinetic energy back into potential energy. It's a continuous, beautiful, and energy-efficient cycle. A planet's orbit is not a monotonous circle, but a breathing, pulsing ellipse, a graceful dance of energy exchange that has continued for billions of years. Isaac Newton provided the universal why with his law of universal gravitation. He showed that the same force that makes an apple fall to the ground is the force that holds the moon in orbit around the Earth and the Earth in orbit around the sun. It is a force that acts across the vacuum of space, proportional to the product of the masses and inversely proportional to the square of the distance between them. This mathematical relationship is the engine of the balance. It dictates the exact speed required for a stable orbit at any given distance. It is the universal rule that governs the motion of everything, from the dust motes dancing in a sunbeam to the grandest clusters of galaxies. This gravitational balance even explains the shape of our solar system. Why do all the planets orbit in roughly the same plane? The solar system formed from a vast, rotating cloud of gas and dust. As this cloud collapsed under its own gravity, it began to spin faster, conserving its angular momentum, much like a figure skater pulling in her arms. This spinning cloud flattened into a disk, the protoplanetary disk. The planets then formed from the material in this disk, inheriting its motion. This is why the solar system is flat, like a vinyl record, with the sun at the center and the planets tracing grooves around it. The original spin of that ancient cloud is the reason we have a stable, orderly system instead of a chaotic swarm of worlds, crossing paths and colliding. But the architecture extends its influence even to the fine details, to the small nudges and tweaks that keep the system refined over eons. This is the realm of orbital resonances. Sometimes, the gravitational poles between orbiting bodies can sync up in simple, stable ratios. A stunning example can be found orbiting Jupiter. 3 of its largest moons, Europa and Ganymede, are locked in a precise orbital resonance. For every one orbit that Ganymede completes, Europa completes exactly 2, and Io completes exactly 4. This 1 to 2 to 4 ratio is not a coincidence. It's a stable configuration maintained by gravity. As these moons periodically align, they give each other a consistent, gentle, gravitational tug. This repeated, rhythmic interaction keeps their orbits stable and predictable over the long term. But this stability has a dramatic side effect. The constant, rhythmic tugging stretches and squeezes the moon's interiors, generating immense tidal friction and heat. Io, the innermost of the three, is the most volcanically active body in the entire solar system. Its surface constantly remade by eruptions fueled by this gravitational dance. Europa, meanwhile, is believed to harbor a vast global subsurface ocean of liquid water, kept warm by this same internal heating, a potential habitat for life. Here, stability does not mean stillness. It creates dynamic, living worlds. We see this same principle of resonance sculpting the rings of Saturn, creating gaps and waves, and we see it in the asteroid belt, where gaps, known as Kirkwood gaps, are cleared out by resonances with Jupiter's powerful gravity. This leads us to the grandest scale of this invisible architecture, the galaxy itself. The Milky Way is not a solid wheel. It's a fluid, dynamic collection of billions of stars, gas, and dark matter, all orbiting the central hub. And just like the planets in our solar system, they obey the laws of gravity. But here, the balance is more complex, and it involves the most mysterious component of the cosmos, dark matter. When astronomers first measured the rotation speeds of stars in distant galaxies, they expected to find that stars farther from the center would move more slowly, just as Pluto orbits the Sun more slowly than Mercury. But to their astonishment, they found that the orbital speeds of stars remained roughly constant out to the very edges of the galaxy. This was impossible according to the visible mass of stars and gas. There simply wasn't enough gravity to hold these fast-moving outer stars in their orbits. They should have been flung out into intergalactic space. So, our journey is a spiral within a spiral within a flow. We spiral around a moving sun, which spirals around a moving galactic center, which is falling towards a neighbor in a larger cosmic dance. There is no fixed point. There is no center. There is only relationship. There is only motion relative to other motion. This brings us to the most mind-bending implication of all. If there is no fixed point, no absolute here or there, then what is the nature of the space through which we are moving? We have been thinking of space as a static stage, a container within which the actors of planets and stars move. But this, too, is a classic, intuitive, and ultimately incorrect view. According to Einstein's theory of general relativity, space is not a passive stage. It is a dynamic participant. Mass and energy tells spacetime how to curve, and the curvature of spacetime tells mass and energy how to move. The space through which we are spiraling is not flat and empty. It is curved, warped by every star, every planet, every speck of dust. The sun sits in a gravitational well, a depression in the fabric of spacetime, and the Earth moves along the curved geometry of that well, which is what we experience as an orbit. But there's more. Space itself is stretching. The universe is expanding. This expansion is not like an explosion hurling galaxies through a pre-existing space. It is the very fabric of space itself growing, carrying the galaxies along with it. On the largest scales, this expansion dominates. Distant galaxies are receding from us because the space between us is literally getting larger. This means that as we trace our beautiful, complex spiral path through the Milky Way, the very metric of space, the grid against which we might try to measure our journey, is itself evolving. The distance between galactic points is not constant over cosmic time. We are moving through an expanding, dynamic medium. All of this, the helical path, the galactic merger, the curvature and expansion of space, paints a picture of a universe in a state of constant, evolving flow. Stability is not the opposite of this flow. It is a temporary, local pattern within it, like a stable whirlpool in a flowing river. The whirlpool has a recognizable form, but the water composing it is constantly new. The water is flowing. Our solar system is a stable pattern, but the universe is flowing through us and around us. We are part of this cosmic current. The atoms in your body, the carbon, oxygen, and iron, were forged in the hearts of stars that lived and died long before our sun was born. Those stars themselves moved on their own spiraling paths through the galaxy. When they died in supernova explosions, they scattered these newly forged elements into space. This stardust then became part of the interstellar clouds that would eventually collapse to form new solar systems, including our own. The spiraling path of our solar system, therefore, is not just a geometric fact. It is a historical pathway. It is the route that this particular collection of stardust has taken through the galaxy. You are not just a passenger on this spiral. You are a part of the spiral itself. The atoms that form your thoughts, your memories, your very sense of self, have been on this journey for billions of years. They have spiraled through multiple generations of stars, across vast galactic distances, to come together here and now, in this specific turn of the helix, to form a being that can look back and trace the path. This transforms our journey from a mere physical trajectory into a narrative. It is the story of matter organizing itself into increasingly complex forms, from atoms to stars, from stars to planets, from planets to life, and from life to consciousness. Our spiraling path is the setting for this story. The stability provided by the invisible architecture was the necessary condition for the story to unfold. The forward motion of the spiral is the arrow of time along which the plot progresses. We are not just moving, we are unfolding. The universe is not a static place we travel through. It is a process, and we are an expression of that process. The stillness we feel is the calm at the heart of this unfolding. It is the peace of being perfectly in sync with a universe that is not a collection of things, but a single, continuous, and evolving event. This understanding brings a final, humbling, and yet strangely comforting perspective. We often fear our own insignificance in the vast cosmos. We are a pale blue dot, a speck on a speck. But if the cosmos is not a static backdrop, but a dynamic, unfolding story, then our significance is not defined by our size, but by our participation. We are the universe becoming aware of itself. We are the part of the cosmos that can look out, trace the spiral, understand the architecture, and feel the profound mystery of the journey. We are the universe's way of knowing its own story, and the story is not over. The spiral continues. The helix unwinds into a future we can only dimly perceive. The merger with Andromeda awaits. The sun will age and change. The galaxy will evolve. The universe will continue to expand and cool. But here, now, at this unique coordinate on the spiral, we have awakened. We have felt the stillness and discovered the motion. We have seen the balance and traced the path. We have learned that we are not just on a journey through the galaxy. We are the galaxy's journey, a temporary, conscious pattern in the eternal, unending spiral of cosmic evolution, the life and death of our sun. For 4.6 billion years, this star has been the anchor of our spiral, the engine of our world, the source of the light and heat that made life possible. But it is a finite engine, burning through its fuel at a prodigious rate right now. The sun is in the prime of its life, a stable main sequence star, fusing hydrogen into helium in its core. But this stability is temporary. In about 5 billion years, the hydrogen in its core will begin to run out. The delicate balance between the outward pressure of fusion and the inward crush of gravity will be broken. The core will contract and heat up, while the outer layers of the sun will expand dramatically, swelling to 100 times its current size. Our sun will become a red giant. The transformation will be catastrophic for the inner solar system. Mercury will be the first to go, vaporized, its substance returned to the stellar plasma. Venus will follow, its thick atmosphere stripped away, its surface melted into a global ocean of magma. And then the sun's swollen, tenuous outer atmosphere will reach Earth. The view from Earth, should any witness remain, would be terrifying and sublime. The sun would fill most of the sky, a raging, red-hued wall of fire. The temperatures on our planet would soar to over 1,000 degrees Celsius. The oceans would boil away into space. The rocks would melt, and the very atmosphere would be blown away by the intense solar wind. Earth would be sterilized, its 4-billion-year biological experiment erased, its surface reduced to a molten slag. It is likely that our planet itself would be consumed, spiraling inward through the sun's expanded atmosphere to be utterly destroyed. This is the inevitable fate of our world. The spiral path that has cradled life for so long will, one day, lead it directly into the furnace of its creator. But the sun's death throes are not the end of our spiral story. As the sun expands, its gravitational grip on the outer solar system will weaken. The orbits of the remaining planets will change. Mars may become, for a brief period, a warm world. The icy moons of Jupiter and Saturn, like Europa and Enceladus, will see their frozen shells melt, creating transient deep oceans under a swollen red sun. For a few 100 million years, the habitable zone of our solar system will shift outward, offering a last, temporary refuge for any life or future intelligence that may have arisen there. Eventually, the red giant sun will shrug off its outer layers entirely, creating a beautiful, glowing shell of gas called a planetary nebula. All that will remain of our star is its hot, dense, Cora white dwarf, an Earth-sized ember of carbon and oxygen that will slowly cool over trillions of years, fading from white to yellow to red, and finally to a cold, black diamond in the dark. The solar system, or what remains of it, will be a ghost of its former self. The inner worlds are gone. The gas giants, stripped of their atmospheres, may be reduced to barren cores. The white dwarf sun will be a faint, dying coal around which the debris of its former planets slowly orbits. Our spiral path will continue, but the heart of our system will be dead. And yet, even as our solar system enters its long winter, the larger spiral of the galaxy continues. Our journey around the galactic center is on a collision course. While the Sun is entering its red giant phase, the Milky Way and the Andromeda Galaxy will be in the final stages of their slow gravitational dance. Over billions of years, the two spiral structures we see today will be completely destroyed. They will not crash, but will pass through each other. They're stars too far apart to collide, but their gravitational fields intertwining like phantom hands. Tidal forces will stretch both galaxies into long, luminous streams of stars. The neat, ordered spiral arms will be pulled apart, their stars flung into vast, flooping arcs that stretch across tens of thousands of light-years. The night sky from any surviving planet would be unrecognizable. Instead of a faint, milky band, the sky would be dominated by brilliant, glowing bridges of stars, new clusters igniting from compressed gas, and the brilliant, active cores of both galaxies shining like twin beacons. The only explanation was that there is far more to the galaxy than meets the eye. Vast, invisible halos of dark matter must surround galaxies, providing the extra gravitational glue to hold them together. Dark matter does not emit, absorb, or reflect light, so we cannot see it, but we can feel its gravitational influence. It is the hidden scaffolding upon which the visible galaxy is built. It provides the extra mass, and thus the extra gravity, needed to keep those high-speed stars on the outskirts from flying away. The stable rotation of our galaxy, and indeed the very existence of galaxies as we know them, is a direct consequence of this unseen architect. So, the stability we experience is a multi-layered masterpiece. It is the balance of momentum and gravity that keeps us in orbit. It is the elegant mathematics of elliptical paths and energy exchange. It is the rhythmic synchrony of orbital resonances that fine-tune the system. And it is the hidden hand of dark matter, providing the gravitational foundation for the entire galactic structure. All of this invisible architecture conspires to create the one condition that makes our existence possible: long-term predictability. The sun rises and sets with metronomic regularity. The seasons turn in a dependable cycle. The planets return to their positions in the sky. This predictability is not an accident. It is the direct result of this profound, system-wide stability. It is why we can build calendars, plan harvests, and launch spacecraft to other worlds with pinpoint accuracy, knowing exactly where they will be years or even decades in the future. We live inside a clock of unimaginable size and complexity, a clock whose gears are gravity and momentum, whose springs are dark matter and orbital resonance, and we are a part of its mechanism. Our bodies, our planet, our star are components in this grand, dynamic equilibrium. The stillness we feel is the sensation of perfect balance. It is the quiet hum of a system operating exactly as it should. A system where every force is perfectly countered, every motion perfectly checked. But as we pull back to admire this flawless, stable, and seemingly eternal architecture, a new and unsettling thought begins to form. This balance, for all its perfection, is not static. The universe is a place of constant, slow, inevitable change. The moon is drifting away from us at a rate of 4 centimeters per year, gradually slowing Earth's rotation. The sun is slowly, inexorably growing brighter. And in the far future, our galaxy is destined to collide with its giant neighbor, Andromeda. This forces a question that moves us from the mechanics of our journey to its ultimate meaning. If this perfect stability is not permanent, if the invisible architecture is itself subject to the slow tides of cosmic evolution, then what is the true nature of our voyage? Are we on a circular, repeating path, or is it something else entirely? Is our journey through the galaxy leading us somewhere specific, or are we just drifting on a current with no final destination? To understand the true shape of our journey, we must first shatter a final, deeply ingrained assumption that the center of our orbit is fixed. We picture the sun as a stationary anchor, a lamppost around which the planets dance in obedient circles. But the sun is not still. It is a star with its own destiny, its own path, its own motion. It is a traveler, and we are its companions. Our sun, the heart of our solar system, is orbiting the center of the Milky Way galaxy. It carries every planet, every asteroid, every comet, everything bound by its gravity along with it. This changes everything. Imagine you are walking in a circle around a friend who is standing still. Your path is a simple, closed loop. Your friend is the center. Now, imagine your friend starts walking forward at a steady pace. You continue to walk in a circle around them. What path do you now trace? Not a circle, but a spiral, a corkscrew, a helix. With every step your friend takes, the center of your circular path moves forward. Your motion is no longer just around, it is around and forward. This is the true nature of Earth's journey. We are not just orbiting the sun. We are orbiting a sun that is itself racing through the galaxy at 828,000 kilometers per hour. Therefore, over the course of a single year, as Earth completes its 940 million kilometer loop around the sun, the entire solar system has also moved forward by nearly 7.3 billion kilometers along its galactic path. The Earth does not return to the same point in space. It cannot. That point was occupied a year ago, and the universe has moved on. Let's visualize this. From a perspective high above the galactic plane, if you could somehow freeze the sun in its path and watch only the Earth for a year, you would see a beautiful near-circular ellipse. But if you then let the sun move, that ellipse transforms. It becomes a winding, forward-moving helix. The Earth and every other planet spirals through the galaxy like a thread unwinding from a spool, each loop slightly advanced from the last. Our annual orbit is not a closed ring. It is one turn of an endless cosmic spiral. This spiral is not a flat, two-dimensional shape. The solar system is slightly tilted relative to the galactic plane. Furthermore, the sun itself doesn't move on a perfectly flat path. It oscillates up and down through the plane of the galaxy, bobbing like a ship on a slow cosmic sea. This adds a third dimension to our spiral, a gentle, wave-like undulation that takes tens of millions of years to complete. Our path is a three-dimensional helix, winding through the galactic dark. This changes the very meaning of a year. A year is the time it takes to complete one loop relative to the sun. But, in an absolute sense, in the frame of the galaxy itself, a year is the time it takes to complete one turn of our spiral. We are not running in place. We are advancing. Every sunrise happens in a new location in the universe. Every breath you take is drawn from a different part of the galactic neighborhood. You have never, and will never, breathe the same cosmic coordinates twice. This spiraling path has profound consequences. It means our solar system is a traveler, not a permanent resident of one quiet corner of the galaxy. We are passing through different regions of interstellar space. Currently, we are within a patch known as the local interstellar cloud, a wispy region of slightly warmer, less dense gas. But this cloud is not eternal. In a few tens of thousands of years, a blink in cosmic time, we will have spiraled out of it and into another region with different densities, different magnetic fields, and a different history. The very space through which we move is changing around us. This grand, spiraling voyage also redefines the scale of our history. We often measure deep time against the backdrop of a seemingly eternal, unchanging galaxy. But the galaxy is our vehicle, and it, too, is on a journey. Our solar system has completed approximately 20 full orbits of the Milky Way since its formation 4.6 billion years ago. Each orbit, each galactic year, is a chapter in Earth's biography. Think of it, one galactic year ago. The earliest dinosaurs were just beginning their reign. The supercontinent Pangaea was breaking apart. 2 galactic years ago, complex life was just beginning to crawl onto land. The rocks that would one day hold the fossils of the first amphibians were being laid down. 20 times, our planet has completed this grand spiral, carrying within it the entire unbroken story of life. From the first self-replicating molecules to the first creature to look up at the stars and wonder. This spiraling motion connects us to the deep past in a way a simple orbit never could. The starlight that fell on the faces of those early dinosaurs was filtered through a different interstellar medium than the light that falls on us tonight. They lived in a slightly different galactic environment. We are not just living on an ancient planet. We are living on a planet that has traveled, that has seen different skies, that has been bathed in the light of different stellar neighbors. As we've spiraled through the galaxy's arms, and what of the galaxy itself? Is it a fixed, spinning disk? No. The Milky Way is also in motion. It is falling. It is being pulled by the gravitational tides of the local group of galaxies. A collection of over 50 galaxies bound together by their mutual gravity. The most significant pull comes from our colossal neighbor, the Andromeda Galaxy. Right now, at this very moment, the Milky Way and Andromeda are hurtling towards each other at about 400,000 kilometers per hour. This means our spiral path is not even a straight spiral. It is a curve within a curve. We are spiraling around a galactic center that is itself moving on a collision course with another galaxy. Our solar system's beautiful helix is itself being woven into a larger, more complex pattern, the dance of galaxies, in about 4 billion years. The Milky Way and Andromeda will begin their long, slow, silent merger. It will not be a violent crash of stars, but a graceful, gravitational intertwining that will last for billions of years. The two spiral structures will be stretched and distorted into long, luminous tidal tails of stars. Eventually, they will settle into a new, larger, elliptical galaxy, an entirely new cosmic city. During this merger, our solar system's spiral path will be profoundly perturbed. We may be flung out into the galactic halo, or drawn closer to the tumultuous center. The night sky for any life that remains will be transformed beyond recognition, filled not with a band of faint light, but with blazing arcs and streams of stars from the merging galaxies. I want you to go outside and watch the sun as it touches the horizon. Watch as that brilliant orb seems to sink slowly, majestically, below the edge of the world. The sky ignites in color, and darkness begins to gather. It's a universal experience, one of the most beautiful and dependable events in our lives. And what you are witnessing is not the sun moving down. You are witnessing the earth turning you away from the sun. That setting sun is the most profound daily proof of our rotation. But it's a proof we have been misinterpreting for millennia. To our ancestors, it was obvious the sun was moving. It rose in the east, traveled across the sky, and set in the west. The logic was simple and seemingly irrefutable. But then, a few brave minds began to ask a dangerous question. What if it's the other way around? The first, and perhaps most powerful, piece of evidence for a moving Earth came not from looking at our own planet, but from looking out at the other worlds in our solar system. In the early 1600s, Galileo Galilei pointed his newly built telescope at Jupiter. What he saw shattered the ancient idea that everything revolved around us. He saw 4 small moons, clearly orbiting Jupiter. Here was a miniature solar system in action, proof that celestial bodies could, and did, orbit something other than the Earth. If moons could orbit Jupiter, then why couldn't Earth orbit the Sun? He also observed Venus. He saw it go through phases, just like our moon, from a thin crescent to a full disk. This was only possible if Venus was orbiting the Sun, and its changing position relative to us, and the Sun caused the different portions of its illuminated face to be visible. The Ptolemaic system, with Earth at the center, could not fully explain this. The Copernican system, with the Sun at the center, predicted it perfectly. The evidence was in the sky, written in light. But this created a new and powerful objection. If the Earth is spinning so rapidly and orbiting the Sun, why isn't there a constant hurricane-force wind blowing from the east as we spin into the atmosphere? Why, when we jump straight up, do we land in the exact same spot? Shouldn't the ground have spun hundreds of meters away beneath us? The answer, as we touched on before, is inertia. An object in motion stays in motion. The atmosphere, your jumping body, all of it, is already moving at the same rotational velocity as the ground. When you jump, you retain that sideways motion. You are not just jumping up. You are jumping up while also moving eastward at 1,670 kilometers per hour. The ground is doing the same. There is no relative difference, so you land right back where you started. It's the same principle that lets you toss a ball straight up and down in a moving car. The ball shares the car's forward motion, but proving this required more than just logic. It required making the invisible visible. And one of the most beautiful and direct demonstrations of Earth's rotation was devised in the 19th century by a French physicist named Léon Foucault in Iba-Wu-Yi, beneath the Grand Dome of the Pantheon in Paris. Foucault hung a 28-kilogram brass-coated lead bob from a 67-meter-long wire. This was no ordinary pendulum. It was a massive, carefully engineered instrument designed to swing for hours with minimal interference. He pulled it to one side, sealed it with a cord, and then lit the cord with a flame. The cord burned through, and the pendulum was released, set in motion to swing in a single, pure plane, according to Newton's laws. A pendulum should maintain its plane of swing unless acted upon by an outside force. As the hours passed, the audience watched in astonishment as the pendulum's swing slowly, inexorably, began to rotate. It wasn't the pendulum that was turning, it was the earth rotating beneath it. The pendulum's swing was tracing a line through space, while the floor, the building, and the city of Paris itself were turning. Over the course of a day, the plane of the swing completed a full circle. Foucault's pendulum made the rotation of the earth a spectacle one could witness with their own eyes. It was no longer an abstract mathematical concept. It was a physical, observable fact. If you ever have the chance to see a large Foucault pendulum in a museum, stand and watch it for a few minutes. You are not watching the pendulum turn. You are watching the world turn you, but the rotation is only one layer. What about our grand orbital journey around the sun? How do we prove we are moving at 107,000 kilometers per hour along a path nearly 1 billion kilometers long? The evidence for this is written in the stars, but it requires patience to see. It's a phenomenon called stellar parallax. Hold your finger up in front of your face and close one eye. Now switch eyes. Your finger appears to jump against the background. That's parallax, the apparent shift in position of a foreground object against a distant background when viewed from two different points. Now, imagine your two eyes are the Earth. At two opposite points in its orbit around the Sun, 6 months apart. The distance between these 2 points is about 300 million kilometers, a massive baseline. If you look at a relatively nearby star from one point in our orbit, and then again 6 months later, that star will appear to have shifted its position slightly against the backdrop of much more distant stars. This shift is incredibly tiny because the stars are so mind-bogglingly far away. It's like trying to detect the shift of a coin that's several kilometers distant. For centuries, astronomers searched for this parallax and couldn't find it, which actually became an argument against a moving Earth. But the real reason they couldn't find it was because their instruments weren't precise enough, and the stars were farther away than anyone had imagined. It wasn't until 1838 that German astronomer Friedrich Bessel successfully measured the parallax of a star called 61 Cygni, finally providing direct full geometric proof that we were indeed moving through space on a vast orbit. This orbital motion reveals itself in another, more subtle way throughout the year. It's the reason we see different constellations in different seasons. As we orbit the sun, our nighttime view of the universe changes. The stars that are visible in the midnight sky in July are behind the sun in January, lost in its glare. The cycle of the constellations is a direct reflection of our annual journey. Now, we come to the grandest motion of all, our sun's orbit around the galaxy. Proving this is the work of galactic astronomy, and it relies on mapping the structure and motion of the Milky Way itself. How do you map a city you are living inside of? You can't just step outside for a photograph. You have to painstakingly measure the positions and distances of its inhabitants. This is what astronomers like Harlow Shapley began to do in the early 20th century. By studying globular clusters, dense spheres of ancient stars that orbit the galactic center, Shapley was able to triangulate our position. He found that these clusters were not centered on our solar system, but on a point far away in the constellation Sagittarius. This was the true gravitational center of our galaxy. We were not at the center of the Milky Way. We were in the suburbs, about 27,000 light-years out. But how do we know we're moving around it? The proof is in the Doppler shift. You've experienced this with sound. When a bambulance races towards you, its siren has a higher pitch. As it races away, the pitch drops. The sound waves are compressed as it approaches and stretched as it recedes. Light behaves in the same way. When we look at the stars in the direction of our orbital motion around the galactic center, their light is very slightly blue-shifted. When we look at stars in the opposite direction, behind us in our orbit, their light is slightly red-shifted. By meticulously measuring these tiny shifts in the light of countless stars, we can map the rotation curve of the Milky Way. We can see that stars closer to the center orbit faster, and stars farther out orbit more slowly. And our sun, in its middle-aged position, moves at that staggering 828,000 kilometers per hour. And there is one final, ultimate proof, a proof that measures our motion not just within the galaxy, but against the entire universe. This is the cosmic microwave background, CMB, the faint afterglow of the Big Bang that fills all of space. It is the most perfect, uniform thing we can observe, but it has a faint, telltale imperfection. When we map the CMB across the sky, we find that one hemisphere is ever so slightly warmer, and the opposite hemisphere is ever so slightly cooler. This isn't a feature of the CMB itself. This is our own motion imprinted upon it. We are moving so quickly through space that the CMB radiation in the direction we're heading appears blue-shifted and thus warmer, while the radiation behind us appears red-shifted and cooler. This dipole anisotropy is the ultimate reference frame. It tells us that relative to the rest frame of the universe itself, our local group of galaxies is speeding at over 1.3 million miles per hour towards a region of space in the constellation Centaurus, pulled by the gravitational influence of something cosmologists call the Great Attractor. So, the proof is everywhere. In the swing of a pendulum, in the shifting of a star's position, in the changing night sky, in the stretched light of distant suns, and in the ancient heat of creation itself. We are surrounded by the fingerprints of our own motion. We have learned to read them.